Okay, today we are going to talk about how to write the ionic formulas for ionic compounds. So we're going to talk about how to write the symbols and the numbers based on a given ionic name. So in order to determine whether you have an ionic compound, you always ask yourself, is there a metal in the compound? So on the test or quiz, you're going to have all these different formulas and names, and so you have to make sure that you have an ionic compound before you do the rules that we're going to see today. So if your answer is yes, there is a metal, you have an ionic compound. If the answer is no, remember you have a covalent compound. And we will do those rules on a different day. Okay, so if you take a look at these examples, remember that an ionic compound has a metal in it, and if there is a metal, it'll be listed first. The second element is always a nonmetal. So you can quickly look at the name of a compound and determine whether it's ionic or covalent. And remember that ionic compounds transfer electrons. They form ions with positive and negative charges. Covalent compounds, remember, share electrons and become molecules. So sodium chloride has a metal in it. Sodium chloride has a metal in it, so it is going to be ionic. Nitrogen dioxide, two nonmetals, so it'll be covalent. Aluminum oxide has a metal, so it will be ionic. Potassium nitride will be ionic. Cesium bromide will be ionic. Carbon dioxide, carbon is a nonmetal, so it will be covalent. Dihydrogen monoxide will be covalent. Sulfur dioxide, two nonmetals, will be covalent. Nitrogen fluoride, covalent. Magnesium oxide, ionic. If you were a little confused on that, go back, press pause, go through those examples slower, and make sure you understand where I got those ionic and covalent labels from. So when you write an ionic formula, now we're just going to focus on ionic compounds, metals and nonmetals. We're going to put the covalent ones aside for a couple days. So the ionic formula is written the following. You will be given the name of an ionic compound. You're going to write the symbol of your metal and your nonmetal from the periodic table. Second step is to write the oxidation number of each ion. We learned a couple days ago that the oxidation numbers can be found easily from the periodic table. They increase, +1, +2, +3, and then group 4, positive or -4, and then the oxidation numbers go -3, -2, -1. So you write those oxidation numbers as superscripts, as top numbers. Then you're going to drop the plus or minus sign, and then you're going to crisscross them, and they're going to switch places to the bottom of the opposite element. And then if the subscripts can be simplified by a least common denominator, then you will simplify them to show the smallest ratio between the two elements. So magnesium oxide, for example, you have magnesium and you have oxygen. So we have Mg and oxide, even though it's not oxygen, we know that it is oxygen because the name of the nonmetal changes to IgE. So magnesium, if you notice, is in group 2. So it's going to have a +2 charge. Oxygen is in group 6, so it's going to have a -2 charge. Then you are going to do what I call drop and swap. Drop and swap means that you don't need these positive and minus signs anymore. And then the superscripts are actually going to drop and swap to the opposite element. So now magnesium is going to have a 2 on the bottom that comes from the oxygen, and oxygen is going to have a 2 on the bottom that came from the Mg. So what that tells you is that for every two magnesiums, there are 2 oxygens. In the final step, if you can simplify the ratio between the 2 elements, you should. So instead of leaving it as a 2-to-2 ratio, we can simplify that to a 1-to-1 ratio, because 2 and 2 are both divisible by a common factor of 2. So an ionic compound shows you the smallest ratio between them if you can simplify. Let's take a look at sodium chloride. Sodium's symbol is Na, chlorine's is Cl. Sodium's oxidation number is +1 from the periodic table. Chlorine is -1. You're going to drop the signs, and then you're going to drop and swap the numbers. So you have Na1, Cl1. You don't write the ones. It's understood that if the symbol is there, then it means that there's one of that element. So you would simply write it as NaCl. Aluminum oxide. Aluminum is Al +3. Oxygen is O2-. You're going to drop the signs, and then you're going to drop and swap the numbers. So this becomes Al bottom 2, O bottom 3. You cannot simplify the 2 into 3, so your final answer is Al2O3. Potassium nitride. So potassium is group 1, nitrogen is group 5. So when you drop and swap, I'm going to kind of do some of these steps together. It's going to be K3N1. Cesium bromide. Cesium is +1. Bromine is -1. So the formula will be CsBr. Barium carbide. Barium is Ba +2. Carbon is -4. You know it's -4 in this situation. Carbon can be plus or -4, but when carbon is bonded to a positive metal, it means that it's going to take on the negative charge. If it was bonded to a non-metal, then it would take on the positive charge. So here we have Ba4C2. Now the 4 and the 2 can be simplified. So we're going to write it as Ba2C1, and you don't have to write the 1 there. Lithium nitride. Lithium is +1. Nitrogen is -3. If I'm going too fast, press pause as I'm talking. Check your periodic table out and see where I'm getting these numbers from. So this is Li3N1. Let's take a look at this. Calcium sulfide. Calcium is Ca +2. Sulfur is S2-. So it'll be Ca2S2, which I'm going to do in a single step to show you that it ends up being CaS. Francium oxide. Francium is +1. Oxygen is -2. This becomes Fr2O1. And again, if I'm going too fast, press pause on the video. Make sure you understand where these numbers are coming from. Aluminum bromide, Al +3, Br -1. So this becomes AlBr3. Gallium chloride, gallium is +3, chlorine is -1. This becomes GaCl3. Strontium oxide, strontium is I don't have my periodic table in front of me while I'm doing these notes. So Sr, I believe it is +2. Oxygen is -2. If I'm wrong, I'm sure you guys will tell me about it tomorrow. Dropping and swapping and simplifying is SRO. Which means that all the other ones we've done so far, I have memorized their oxidation numbers. Just that one I sometimes get confused with. Sodium is Na +1, fluorine is -1, so it becomes NaF. Gallium is +3, iodine is -1, so it's GaI3. Barium chloride, Ba +2, Cl -1 becomes BaCl2. Okay, and that is where we will end for today. Now, in the next set of notes, what you will see is we are going to do writing ionic formulas again. But if you have a transition metal, there's something a little extra you have to add. And if you have a polyatomic ion, we'll talk about how to write the formulas for those as well. So this is only if you have a normal binary, normal group 1, group 2, group 3 metal, and a normal non-metal.